All right, section 12-4, angle measures and segment lengths. So we're going to underline the correct word to complete each sentence. So the student went off on a tangent when he did not stick to the subject. A tangent to a circle intersects a circle at exactly one point. From a point outside a circle, there are two tangents to a circle. All right, so secant. It's a noun. A secant is a line that intersects a circle at 2 points. The word secant comes from the Latin verb secare, which means to cut. So in the diagram at the right, line AB is a secant. Ray AB and ray BA are secant rays. And line segment AB is a secant segment. All right, so write the word secant or tangent to identify each one. So in number 4, we have a secant. In number 5, we have a tangent. In number 6, we have a tangent. In number 7, we have a secant. Is a chord a secant? No. Okay, a secant contains points outside a circle, while a chord does not. All right, theorems 1213, 1214, and 1215. So 1213, the measure of an angle formed by two lines intersect inside a circle is half the sum of the measures of the intercepted arcs. So the measure of angle 1 is half of the sum of x plus y. Okay, so in a diagram at the right, does the measure of angle 2 equal half of x plus y? And the answer would be yes. Okay, so angle 1 and angle 2 are vertical angles. So the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals 1/2 the sum of x plus y by the transitive property of equality. All right, theorem 1214. The measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arc. So the measure of angle 1 is equal to 1/2 of x minus y, so the larger minus the smaller. So in the first diagram, the sides of the angle are a secant and a secant. So two secants. Number 11, the sides are a secant and a tangent. And in number 3, the sides are a tangent and a tangent. So the measure of angle 1 is 1/2 y minus x equivalent to 1/2 of x minus y. The answer is no. So the larger minus the smaller. All right, theorem 1215. For a given point and circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point and the circle. So here are 3 cases, 1, 2, and 3. In case 1, we know A times B equals C times D. In case 2, we know the sum of W plus X times W equals the sum of Y plus Z times Y. And in case 3, we know that Y plus Z times Y equals T squared. So I like to think case 1 is that the product of the pieces are equal, okay? In case 2, I like to think of it as the whole times the outside equals the whole times the outside. And for case 3, it's the same thing. So it's the whole times the outside. It's the whole times the outside. So you can see how the same thing happens up there. All right, so number 17. So use theorem 1214 to complete the equation. So we know that 70 is going to equal 1/2 of W minus 110. So now let's solve that equation. So we have 70 equals 1/2 of W minus 110. So we have multiply both sides by 2. So we have 140 equals W minus 110. I'm going to add 110 to both sides, so I get 250 equals W. So the value of W is 250. All right, so a Deep Hardy space probe sends back a picture of the Earth as it crosses the Earth's equator. The angle formed by the two tangents to the equator is 20 degrees. What arc of the equator is visible to the space probe? So use 20 FG in the words Earth and probe to complete the diagram at the bottom. So this is the Earth. This is the probe. This is 20 degrees. This is G, and this is F. All right. So let the measure of arc FG equal X, then the measure of FEG is going to equal 360 minus X. So then the measure of angle FPG equals 1/2 of the measure of arc FEG minus arc FG. All right, so now substitute my measures. So 20 equals 1/2 of 360 minus X minus X. So 20 equals 1/2 of 360 minus 2X. Distribute to 1/2, so 20 equals 180 minus X. So we have negative X equals negative 160. So we have X equals 160. All right, problem number 3. All right, so the segments intersect outside the circle. All right, so we're going to write justification. So we know that the whole times the outside, whole times the outside are equal. So we're going to use theorem 12-15 part 2 or case 2. So simplifying by distributing 476 equals 256 plus 16x. So we're going to simplify. We're going to subtract 256 from both sides. And then we're going to divide by 16. So the value of x to the nearest tenth is 13.8. All right, in the diagram on the right, is it possible to find measures of the unmarked arcs? So you can use intercepted arcs to find the value of y. Yes. You can use supplementary angles to find the value, to find the measures of the angles adjacent to y. Yes. You can find the sum of unmarked arcs. Yes. Is it possible to find the measures of each unmarked arc? No. The sum of the unmarked arcs is not enough information to find the measure of each unmarked arc. And that's the end of this section.